Alright, hello everybody. So next section is on measuring segments. So I've mentioned before the difference between geometry and algebras. In geometry we have a lot of rules, and they're broken up into two categories, postulates and theorems. So we'll talk about a couple postulates today. Postulates generally are much more straightforward. They're not very difficult to understand usually, where theorems, there's usually more to it. I will never ask you, what's postulate 1.1? What's postulate 1.2? You don't have to know the numbers that go with them. I don't know the numbers that go with them. I know what they say though. Not specifically 1.1 says this, but like I referee water polo, and I know all the rules. If you asked me what the number of the rule is, I could not tell you. I could look it up, but I couldn't tell you the rule, and that's okay. So the information is the most important part. So this one is called the ruler postulate. And so it just kind of says if we have a segment from A to B, and I'm going to erase them and put them on top. And we could call this some number x, and this also another number x, so x1 and x2. And you wanted to know how far apart that was. You could just subtract them. But it's the absolute value, because remember, absolute value makes your answer positive, not what's on the inside positive. So if you had a number line and you were at 5 and you were going to 12, well, 5 minus 12, that's negative 7. But distance is never negative. You can't have a negative distance. It's impossible. So the distance would just be 7. Okay, if you walk backwards 7 feet, you didn't walk negative 7 feet. You walked 7 feet, it goes backwards. So negative distance is impossible. It's the same thing up and down. If you had a line like that, this is some number x and some number x. Still just subtract them. Absolute value. Okay, so that'll come into play on a couple problems where it wants to know, it says to plot the points in a coordinate plane to determine if the two things are congruent. So we'll talk about, oh, that's bad. Talk about this word congruent. I don't want to use that equal sign. We use the word congruent. They're the same. They're the same size. They are equal, but you'll see later on in a different chapter, maybe later this chapter, but sometimes we say something is equal, sometimes we say it's congruent. And when the time comes, I'll talk about when we use things that are different. But for now, you can think of it as being equal. Alright, so if I had the problem 6, -1, let's call that point A, and 1, negative 1, and then C was 2, negative 3, and D is 4, negative 3. And so what the directions will say, plot the points on a coordinate. And I'm just going to use this as an example, but I'll show you what you can do. It'll make it faster. So 6, negative 1, and 1, negative 1. And you notice they're straight up and down. They're not diagonal. So C and D, 2, I'm going to do a different color, 2, negative 3, and 4, 1, 2, 3, 4, negative 3. You notice that they are straight sideways. So that'll happen on all the problems you're going to do today of this version. So it wants to know, are those two things the same size? And so if you put them on coordinate plane, you can just count. So from A to B, starting at A, you go up 1, up 2, and from C to D, go to the right 1, to the right 2, and they both equal 2, so you would say yes, they are congruent. So, but one thing that I want to kind of point out, and it is kind of weird in a sense on some of these, but if you notice, I did this wrong. I did the B part backwards. That wasn't very good of me. Just realized that, so my apologies. Let's back up. The B part is not correct. So the B part should be 1, negative 1 right there. Which makes this a big no. Sorry about that. I'm not perfect. I will make mistakes. So I think obviously they're not the same now. But how far is it from B to A? So if you go back up to the points, I think this is the easiest way to do it. Notice that they both have negative 1 for the y part of the coordinate. And when they're the same, you could just do 6 minus 1 for the other part. Say, well, the length of that's going to be 5. And this one happens to all have the y part the same also. It could be the x part's the same. It doesn't change it. So 2 minus 4, negative 2, but absolute value, so the length of that is 2. So sorry about the confusion at the beginning, but if you don't want to do the graphing part, you'll have to graph stuff eventually, but for today, if you notice, hey, those are the same, and you just want to subtract the other value. So if the x numbers were the same, just subtract the y values. And if it's negative, absolute value, make it positive. Okay? Alright, sorry about the confusion there again, but okay, ruler postulate. So you'll have some problems that just ask how long is something. Okay? Or are they congruent, rather. Alright, another postulate. And this one we will use quite a bit in this chapter and in some coming chapters, but segment addition postulate. So a lot of the theorems and some of the postulates are in this if-then format. So it's going to say if B is between A and C, then AB plus BC equals AC. So that might be like, okay, well, you said all these words. What does that look like? B is between A and C. So if I put A over here, put C over here. Now, between does not mean in the middle. Middle would imply that from A to B and from B to C are the same. Between just means somewhere in there. Could be closer to the A, could be closer to the C, it doesn't matter. So it's just saying like, well, and here's where once we kind of nail this all down, it becomes a lot easier to understand. You know, if I knew that was 10 and I knew that was 4, I could just do 10 plus 4 is 14. And I think if I gave you a problem, you would kind of go, well, I could just add those together. Well, that's what the segment addition postulate is saying. But we're going to need to use this, and today it'll be pretty straightforward. But we're going to need to use this segment addition postulate down the road in a different like form. So, you know, you'll need to be able to say, hey, this is segment addition. Or look at a picture and say, well, I could add that and I could add that. And it's going to equal the whole thing. So you'll have some very simple problems dealing with just whole numbers with segment addition postulate. And then toward the end, one last example. So it'll say, you know, kind of the same thing. B is between... That also means it has to be on the same line, A and C. So if a B was on a different line, it's not between A and C, even if the picture kind of looks like it. So B is between A and C, and then it'll say solve for X. So a lot of what geometry is, oh, that's bad, is it's gonna tell us some stuff about geometry. And then we're going to solve an equation, a lot of it, in different like times. So if it said that AB equaled 2x plus 8 and BC equaled x plus 3 and AC equaled 23. So that would be like, you know, the B is between A and C, solve for x's in the directions, and then the other part is the actual problem. So if you wanted to create a visual, you could. So here's A, and maybe B's over here, and C's over here. Well, this is 2x plus 8. Should probably label those. And this is x plus 3. And that is 23. Well, segment addition says that I can do 2x plus 8 plus x plus 3, and it's going to equal AC, or 23. So there's a equation to solve. So I can combine like terms, 3x plus 11 minus 11. That looks like a 4 because I was going too fast. Divide by 3. And x equals 4. So toward the end of your assignment, you're going to have a couple problems to do very, very similar to this one. Okay, so set up an equation and solve it. And again, being between does not mean in the middle. So don't try to imply that they are equal. It's possible, it just doesn't have to be that way. All right, make sure on when you get to the problem that I just did, you got to show your work. I'm looking at some of the problems. On the ones that you have to ask, is it are they congruent? Where I just said, hey, if the x numbers are the same, subtract and so forth. Just write the points down, and then if you just write what you subtracted, that's good. From problems 15 through 21, I don't need to see any work. You can just write the answer. It's pretty straightforward. But the rest of them, I need to see like the work that you did. There's a couple of them that have some like lead up directions. You don't have to write that part down, but just please organize your work. If I can't tell where the work is, I'm going to take points off. Okay, so if on a problem like this, honestly, the work that, like on a problem like this one, that I would need to see is just this. You don't need to write down the other stuff. Okay, just write down like your calculations. But a box around it on your paper, and then a box like for the answer, or circle, that's really what, I should see. Okay? All right. Email me questions, or if you want to wait till tomorrow on the Zoom, we can go over some stuff if you need to. Remember to check your answers. The answers are on the school website on my webpage, so just make sure you go check them out. All right. Have a great day. See ya.